Good morning, Joseph.
Good morning.
Did you get those My Math Lab problems last night?
Oh crap, I knew there was something I missed.
Don't worry. I had several questions, particularly on number 4 and number 5, so we're going to talk about those and then I'll extend the deadline for it.
Okay, thank you.
You're welcome. How about the homework in the book?
Wasn't too bad. Took me a couple watches of the video to understand it, but I got the homework down.
Ah, that's wonderful. Good.
I felt like these were a little bit easier than the other ones.
You mean, yes, the day before, day 1 problems?
Yeah, I felt like they were just a tad easier.
I wonder if they were easier or if you just understood it better.
Probably that.
We may have an audience all to ourselves. Good morning, Mr. Dillon.
Good morning.
Good morning, Ivy.
Morning.
I had some questions on number 4 and number 5 in my math lab last night. Those seem to be the two hardest ones. And Dylan, I answered one email for you last night. I can't remember. I don't think I heard back from you after I answered your email. But what I'm going to do is go over those two problems and then extend the deadline for it so y'all can finish that up. Sound good?
Yeah, that sounds good.
Okay. Well, does anybody have a problem from the book they want to look at before we talk about those two My Math Lab problems?
From the homework.
Yes, homework from the book, page 190.
Number 29.
Number 29. Alrighty. 29. Yes, good old shadow length. And the only difference between 29 and 30 is, I think one of them, the guy's walking toward the light and one of them's walking away from the light. And the 30 was on the video, right, Ivy?
I looked through the video. I couldn't find where you did 30.
Oh, okay. I have it circled, but I may not have gotten to it the day I made the video.
The numbers are different from your videos too because it's the newer book.
Oh, yes. That makes sense. Yeah, I don't redo all the videos every time they come out with a new edition of the book. So maybe that was it. But let's look at number 30. Good morning, Miss Abby.
Good morning.
Number 30 says, repeat exercise 29. So we got to go back and read that again. A man 6 feet tall walks at a rate, ooh, that's not focused yet, I'm sorry. Focus. Okay. A man 6 feet tall walks at a rate of 5 feet per second away from a light. And then the difference in number 30 is he was walking toward the light. Actually, 29 is the one I'm supposed to be doing. A 6 foot tall man walks at a rate of 5 feet per second away from a light that is 15 feet above the ground. And I tried not to look at their picture. Draw my own picture of a light. Here's my very best light. That is 15 feet above the ground. Oh, I know one thing I wanted to say to Dylan and Jacob when you emailed me last night, or it may have just been Jacob. One hint that I didn't think to give you yesterday, don't label anything on your picture that's changing. That autofocus is going squirrely this morning. Okay, don't label anything on your picture that's changing. That 15-foot light pole is not changing, and the 6-foot tall man is not changing. So you can label those, but if you have something else and you're given another number and it represents something that's just one point in time, not fixed, don't write it on your picture. If you write it on your picture, you tend to think it's fixed, and some things aren't. All right, that is my light that's 15 feet above the ground. Hold on, let me let Miss McKenzie in. 15 feet above the ground, and my 6-foot tall man walking at a rate of 5 feet per second from a light, from that light. All right, so here's my ground. Here's the 6-foot tall man. And again, the only reason I'm labeling the 15 and the 6 is because those things aren't changing. Now, the question is, when he is 10 feet from the base of the light, at what rate is the tip of his shadow moving? Well, if he's walking away from the light and the light's behind him, is his shadow going to be behind him or in front of him?
In front.
Speak up just a little bit, Ivy. Ivy.
In front.
Yes, it's going to be in front of him. The tip of his shadow is going to be over here somewhere. So the question is, when he is 10 feet from the base of the light, should I label this side 10 or something about this 10? Is that a fixed distance?
No.
No, that's just some moment in time. So I'm not going to put the 10 on the diagram. How fast is the tip of his shadow moving? Well, the length of his shadow is caused by this light shining down on him. So since I know that this is probably going to have something to do with a triangle, I'm just going to go ahead and say that's what determines the tip of his shadow. The light shining on his head casts his shadow out in front of him. What symbol would you use for his walking pace is 5 feet per second? Or we've got to figure out some other things to put on this triangle. Do you have anything labeled X or Y?
I labeled his distance from the pole as X and the length of his shadow Y.
Okay, that makes sense. Let me talk about other things you could have done. Now that's absolutely fine. If you want to let X be his distance from the pole, and we do need to use a variable for that because that's changing, and you want to let the length of his shadow be Y, then if you need to, what would you use to represent the distance from the pole to the tip of his shadow, if you needed to?
X plus Y.
Sure. And so another thing you could have done, and I'm going to do it the way you did it, but another thing you could have done is let's, for example, this whole distance be X, and then if this was Y, then this would be, wait, I just lost track. If the whole distance was Y, then this distance would be Y minus X. You see what I'm saying? Okay, and you could do it either way. So let's stick with what you said. If we use your labels, then what symbol did you use to represent his rate walking away from the light?
Dx over dt.
That's how fast that distance is changing. So dx over dt is 5 feet per second. All right. What is it that we're trying to find in the A part? At what rate is the tip of his shadow moving?
Oh, dy over dt.
All right. At what rate is the tip of his shadow moving? His shadow is moving away from him. Let me think about that 1 second. At what rate is the tip of his shadow moving? What I'm thinking is whether it means, or whether it would matter if I did the rate at which y is changing or the rate at which x plus y is changing.
I don't think it would matter because y is like the distance of his shadow, so I
Yeah,
don't know.
I don't think so either. I just wanted to think about that a minute. All right, so label your picture with only fixed distances and variables on your picture. Identify the rates that you're given, and then this find statement helps me clarify things in my head. If I say find and then clearly establish what I'm looking for, and then say when, in this case, he is 10 feet from the base of the light, means when what?
Could
Which
you say
variable?
that again? I blinked out.
Oh, that's okay. The A part also says when he is 10 feet from the base of the light. What is that giving you?
X.
So when x equals 10. And again, that 10 is not a constant. That's just some moment in time. He's 10 feet from the base of the light. Now, I think we have everything labeled, and we've identified the rate that we're given, the rate that we're looking for, and the constant, or the variable that we're given. So now we just need an equation. Do you see anything about that triangle that would give you an equation?
Well, I tried using Pythagorean theorem, but I couldn't do it.
And that would probably be my first instinct. 15 squared plus x plus y squared equals, yeah, call that the square root of 15 plus x plus y squared, maybe. That sounds nasty. I'm going to try to avoid that, but I see why you would think that to begin with. Another reason I'm thinking it's not just the Pythagorean theorem is because that doesn't incorporate the 6 in any way. Does anybody have an idea? I'm looking for two specific words. Rather than Pythagorean theorem, what else pops out at you about that triangle? Or I can give you a hint and make it plural. Anybody see something about two triangles there? This little triangle.
It's like a smaller version of the big one.
Looks like a smaller version of the bigger one. What's that called in geometry?
Similar.
Similar triangles. Those are similar triangles. They share I don't want to finish that sentence. They share. It wasn't going to make sense. Those two triangles are proportional to each other. The little triangle is proportional to the big triangle. So what equation could you use based on the fact that my green triangle and my yellow triangle are similar? You see anything?
Oh, you could set up a proportion.
Mm-hmm. What proportion do you see? There's more than one proportion we could use, but what do you see?
X plus y over 15 equals y over 6.
All right, and that's probably not the proportion that would have popped in my head. Probably the proportion that would have popped in my head is y is to x plus y as 6 is to 15. Or maybe, I thought I saw a couple other proportions I could use, but say yours again, Ivy. I want to do it the way you suggested.
X plus Y over 15 equals Y over 6.
Good. That would be big is to big as small is to small. And I'm usually used to setting mine up big is to little as big is to little, but it doesn't matter. The thing is, before I differentiate, I have to make sure that my equation is only in terms of rates that I'm given and rates that I'm looking for. If I have anything other than X's and Y's in here, I'd have to get rid of it. And that happened on one of the homework problems in my math lab last night. We'll talk about that when we get to it. But remember, one step in the box guidelines for solving related rates problems said, make sure your equation is only in terms of rates that you're given or rates that you're looking for. Now, so that I don't have to use the quotient rule, I would probably cross multiply, clean up that equation a bit. 6x plus 6y equals 15y. And also, when it gets way easier when you combine like terms, 6x equals 9y. Why don't we just call it y equals 2/3 x? Pretty cool that it turned out that easy. Now we wouldn't have a problem finding dy when x is 10.
Yeah.
Differentiate both sides, dy over d what?
T.
Because we're differentiating with respect to time, dy over dt equals, what would that right-hand side be when you differentiated with respect to time?
2/3 times dx dt.
Good. Hey, what does that tell you that this equation no longer has an x in it? Oops, typo. It has a dx over dt, but I don't really have anywhere to plug this 10. What does that mean about the rate at which the shadow is changing?
It's directly proportional.
Oh, good. I didn't think of those words, but you're right. When one thing is a constant times another thing, that is directly proportional. I was thinking the rate at which the shadow is moving doesn't depend on how far away the man is from the pole, because that's what X represents. But that's two different ways. Yeah, that's two different ways of saying the same thing. So now if I just put the 5 in place of dx over dt, I'll have what I was looking for in the A part. So I think on that one, Ivy, it was just you didn't think to use similar triangles. You could probably do the B part now, right?
Yeah, I can do it, thanks.
Awesome. All right, does anybody have another one from the book? And then we'll talk about those from my math lab. Anything else from the book? But y'all did them, right? You didn't just do the 6 problems I gave you in my math lab. Or did I? Yeah, I gave you 6.
I actually have a question about the B part because it looks like the exact same question.
Okay, I bet I know what you're talking about. The B part, I labeled that 30, but that's actually 29. And that's the A part. The B part says, when he is 10 feet from the base of the light, at what rate is the length of his shadow moving? What would you use for the length of his shadow?
Why?
Yes, something's bugging me.
I think we did B part and A part.
I think we did. If y is the length of his shadow, then dy over dt is the rate at which the length of his shadow is moving, not the length at which the tip of his shadow is moving. So you're exactly right. dy over dt is the rate at which the length of the shadow is moving. Which means a minute ago when I stalled out and I wanted to think just a second about whether we should have in the A part said dy over dt or d of x plus y over dt. The way that you labeled your picture, y is the length of the shadow, x plus y is the distance from the tip of the shadow to the base of the light. So you're right, we did the B part in A, or we did the B part first. Tell me what,
I think
tell
I
me
can
what
do
I'm looking for in the A part to answer the question. At what rate is the tip of his shadow moving?
I would change how I label it and have X be the whole thing now.
I probably wouldn't relabel. I would just say the distance that his shadow is from the pole is x plus y. So I'm looking for d of x plus y over dt. And if I have d of x, and I have right here, d of y would be 2/3 times 5 or 10/3 feet per second. I'm thinking one jiffy again. Because this is your labeling was different than my labeling, so I'm having to double check everything. But since we can differentiate term by term, this is the derivative of x with respect to t plus the derivative of y with respect to t. And so that's going to be the 5 plus the 3 1/3 is 8 1/3. Now, I actually want to check that before I move on. Oh, shoot. I don't have that answer written down. Does anybody have the answer for A and B?
Those are both right.
Those are both right. Whew. See, it seemed very different to me because I labeled my triangle differently. Instead of x and y and x plus y, I had x and the whole thing being y and the length of the shadow being y minus x.
Yeah, that's what I did.
Okay. And if it makes sense, it seems like I pulled a little hocus pocus right here, but we can differentiate term by term. You can also think if the man is walking at a rate of 5 1/3 feet per second and his shadow, the length of his shadow is changing at 10 1/3 foot per, or 10/3 feet per second, then the rate at which the tip of his shadow's moving is the sum of those two. How fast he's moving plus how fast the length of his shadow is changing. All right. That one's a little bit harder for me with the picture labeled the way that you labeled it, Ivy, but you can still get it.
Okay.
What else from the book? Anything? Going once. Going twice. All right. talk about 4 and 5 from my math lab. Those were the two that I got the most questions about. And I'll get you started on both of them, and then I'll extend the deadline to let you finish them up. I don't have the exact wording on number 4 in front of me. I drew a picture and worked it out on paper, and I think I can remember basically what the wording was based on what my picture looks like. But I think Jacob emailed me about this one, and my primary advice to him was, don't put any numbers on your picture that don't represent fixed distances. If it's a fixed distance, like the height of a light pole or the height of a man, go ahead and put it on there. But you need to use variables for everything else because you have distances that are changing. So number 4 said something like, a child is flying a kite at an altitude of 90 feet. Now, is the height of the kite changing based on that sentence? It's kind of counterintuitive because it would be pretty difficult to maintain a certain height with a kite. It's going to be swooping up and down. So you're not going to have a constant height of a kite in real life. But this problem says the child is flying the kite at a height of 90 feet. So actually in this problem, that 90 feet's not changing, which means you can go ahead and label it on your picture. And then it says, what did it say? The wind is blowing the kite such that, what was the rest of that sentence? I know this is the distance between the child and the kite as the kite's being blown away from the child horizontally. I think it just said the wind is blowing the kite such that it is the horizontal distance away from the child is, and it probably gave all of us different numbers. The number that it gave me was 30 feet per second. It said something like the rate at which the horizontal distance of the kite is away from where it began is 30 feet per second. And so that's the horizontal distance. And any, mini, miny, mo, you have to let something be the distance between the child and where the kite blows to. So I let that distance be S. If the problem said, find the rate at which the distance between the child and the kite is increasing, how would you start, or how would you finish this sentence? Find what? The rate at which the distance between the child and the kite is changing.
ds over dt, right?
Say that louder.
ds over dt.
Yeah, that's what I have labeled S on my picture. S is the distance between the child and wherever the kite blows to. So I'm looking for ds over dt. And then it gave me when the distance from the child to the kite is 150 feet. How would I finish that sentence? When, which one of my variables is 150?
X.
It says when the kite is 150 feet from the child.
Would it be S then?
Yeah,
Okay.
because the kite started here, but it ended up over here at the same 90 feet altitude, but it's further away from the child than it was when the kid just got it to fly straight above it. So it's when the kite is 150 feet away from the child is when S is 150 feet. So the two recommendations that I had, and I keep stressing these because these are the two things that helped me the most. The two recommendations I had for Jacob last night: don't put anything on your picture that is changing. Don't put any numbers on your picture that are changing. This 90 is fixed, but I don't need to put S equals 150 on my picture because that's just at one moment in time. I need to use a variable for S and a variable for X. The other thing that I told Jacob was, this sentence helps me so much. It clarifies what I'm looking for, and it clarifies the fact that this is something that's changing. It's just 150 at one moment in time. Now, the second thing, if we call the picture the first thing, and this statement my second thing, then the third thing is write an equation that relates quantities for which the variable is given, or the variable, let me try again. The quantities for which the rate is given, or we're looking for the rate. In other words, we need an equation that has X's and S's in it, because that's the rates that we were given or the rate that we're looking for. So look at my triangle and give me an equation that has S's and X's in it. Miss Abby, how about it?
X squared plus 90 squared equals S squared.
Absolutely. And what does the fact that when you differentiate both sides with respect to time, what does the fact that the derivative of 8,100 is 0 tell you? What does the fact that that 90 disappeared tell you?
It's constant.
It's a constant, and it wouldn't have mattered what that constant was. Even if the child was flying the kite at a height of 50 feet and I had 50 squared here, it still wouldn't affect this equation. So that altitude has to be a constant, but it doesn't matter what the constant is. All right, we were looking for ds over dt, so I'm going to just divide both sides by 2 and put 30 in place of the x, and no, I'm sorry, that's the dx over dt. Funny that I erased that just to move it over a centimeter. 30 dx over dt is 30, and we're supposed to let, darn it, I had something to plug in the place of dx over dt. That was my 30. I had something to plug in the place of the s. That was my 150. I didn't need anything to substitute in the place of this because that's what I'm looking for. And I did to go ahead and divide both sides by 2. But what about the fact that that still has a variable in it? What am I going to do about that?
Solve for x with the Pythagorean theorem.
Using what for the other side?
150 on s.
Right. At the moment when s is 150, then you have 90 and 150 and x. You can find a particular value of x at that moment and use it for x. Because when when S is 150, X is a definite value. It has, it's a constant, not a variable at that moment. So I'm going to say solve for X and then substitute it right here and let you finish that one. Okay? Any questions? All right. Let's talk about number 5. It had sand falling onto a sand pile. There was a problem like that in the text homework, but as sand falls from some kind of spout onto this pile, the pile becomes a triangle, or I should say a cone since it's 3-dimensional. All right, I think we were given the rate at which the sand pile builds. Would that be a radius, a base, a height, a volume, a what? I'll give you a hint. The units were cubic feet per minute. Cubic feet per minute is a what? Or what's measured in cubic feet?
Volume.
The volume is measured in cubic feet. So you can get a clue from what the units are. If they're squared, then you're talking about area. If they're cubed, you're talking about volume. If they're linear, you're just talking about distance. So we're given that the change in volume is 15 cubic feet per minute. And then we're told something. Let me see if I can remember what this sentence says. The height is 3/8 of diameter is what my problem said, and you probably had a different number in yours. I'm going to make my sand pile a little bit bigger so I have room to write in it. What's important in that sand pile? What quantities do we need to identify? Our rate that we're given pertains to volume. So what's the volume of a cone? And you could look that up, or I'd give it to you on the test. Anybody look it up?
1/3 pi r squared h.
Right. So in calculating the volume of the cone, what are the important quantities involved? What 2 things do the volume of the cone depend on? Y'all are making me a little bit nervous. My formula has R's and H's in it.
Radius and height.
Yeah, so the volume of the cone depends on the radius and the height. So at any particular time, I need to talk about the height of the sand pile at that moment, and I need to talk about the radius of the sand pile at that moment. And this introduces a third variable, diameter. but you tell me something about diameter and I can figure out how that affects the radius. So this sentence, if you wrote height equals 3/8 of diameter, and this equation doesn't have diameter in it, how could you change that to something about the radius?
Height equals 3/8 2r.
Yeah, the diameter is exactly 2 radii. So the height is 3/4 of the radius. No matter how high the sand pile is, the height is always 3/4 of the radius because of this sentence. All right, I think this problem had an A part and a B part. One of the two parts, or they weren't labeled A and B, but one of them said find the rate at which the any, mini, miny, mo, let's say height is changing. And mine said when the height is 2. Find the rate at which the height is changing. If I define which rate I'm looking for or which quantity I'm looking for, what would it be in this part? What symbol stands for the rate at which the height is changing? And gonna go away if y'all don't talk to me. Miss Grace, are you here today? And Miss Autumn's laptop crashed. And I haven't heard Jacob. Mackenzie, what symbol do we use for the rate at which the height is changing?
dH over dt.
Yeah, find dH over dt when h is 2. Now here's the thing to watch for here. Again, that step, the step in the box, I think it was step 3 in the box, said write an equation in terms of only variables whose rates are given or whose rates we're looking for. In other words, I can't differentiate this equation yet because I have a rate for V, I'm looking for a rate for H, but I don't know anything about R. I have to put something in place of that R. I have to get this equation only in terms of V's and H's before I differentiate. So what could I put in place of that R?
4/3 H.
Sure. If H equals 3/4 R, then R equals 4/3 H. So 4/3 H is what I'm going to put in place of this H, and then I'll be able to differentiate. 1/3 pi times 4/3 H squared times another H. And I'd like to clean that up. That is 16/9 times 1/3 is 16/27 pi H cubed. Am I ready to put the 2 in place of the H yet? No, because I haven't done what?
Differentiated.
I haven't differentiated yet. Get your equation in terms of rates that are given or rates that you're looking for, and then differentiate. So dV over dt would be 16/9 pi h squared. And don't forget what else.
dH over dt.
Right. We have a number we can put in place of dv over dt. We have a number we can put in place of h. And we have a number we can, or we're solving for dH over dt. Now, the B part, which I won't do, it says find the rate at which the radius is changing. That means I need this formula in terms of only dv over dt and dr over dt. I don't need to have h's in it. So I can substitute h equals 3/4 r, and I could put 3/4 r in the place of that h. But when I get down to the point where I've differentiated, my equation is going to have a dv over dt in it. It's going to have a dr over dt because that's what I'm looking for. Excuse me, what I'm looking for. But it's also going to have an r in it, and I don't have anything to substitute in place of r. What can I do about that? What's that? Here's what the B part says. But I'm going to have an equation with r's in it, not h's.
Would you put 3/4 r in place of h?
That's what I'm going to do to get the equation. Let's see. B equals 1/3 pi, and then 3/4 h, no, 3/4 r in the place of h. What's bugging me? 1/3 pi. Oh, that's my h. Pi r squared h. And so my equation does only have r's in it. That's not the problem. That would be 1/4 pi r cubed. The problem is when I differentiate, I'm going to have, I'm going to need an r to substitute into that value, and I don't have an r, I have a h.
You find the r by in the r equals 4/3 plugging in the 2.
Yes, I know that r is always 4/3 h. So when h is 2, r is 4/3 of 2, or 8/3. So after I differentiate, I'm going to put the 15 in place of dv over dt, and I'm going to put 8/3 in place of r, and then I'm solving for dr over dt. So it's just like Joseph said here. At some particular moment in time when s is 150, you can find x. And when h is 2, you can find r. But those aren't fixed values. Those are just some moment in time. All right. Like yesterday, I'll send you a remind, or I'll send you an email and then a remind about tonight's homework. I'll have to look in my math lab and see if there are any other good, not too difficult problems that I can put in my math lab, or whether I just want you to take a picture of a couple problems you do from the book. But anyway, finish up 3.7, whatever you haven't done, and we skipped 3.8. So 4.1 is what we'll be talking about Monday. And there aren't any notes for 4-1. I just do a lot of examples from the book. Okie doke.
Artichoke.
Okay. All right. Y'all have a good weekend, and email me if you need any more help with the homework. I'll extend that deadline right now. Y'all have a good weekend.
Bye.
Bye-bye.